Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 38, and we're given this structure here, and we're asked three things. A, how many pi electrons does C contain? B, how many pi electrons are delocalized in the ring? And C, explain why C is aromatic. Well, let's start with A. How many pi electrons does C contain? So we know that pi electrons are your double bond electrons. So we have the single bond, which is a sigma bond, and double bond is the pi bond. And you know that any additional pi bonds or additional bonds are just additional pi bonds. So each bond is composed of two electrons. So each one of these pi bonds have two electrons. And if we count, we have 2, 4, 6, 8, 10, 12, 14, 16 total pi electrons. Now, B asks how many of these pi electrons are delocalized in the ring. So what we know is that for an alkene double bond, we know that the p orbitals are actually facing perpendicular to the sigma bond orbitals, which are in the plane of the bond being formed. So because these p orbitals are perpendicular, they can actually overlap with each other pretty well on top and on the bottom of the sigma bond orbitals. So because of that, they're able to interact and do what we say is delocalization with all the adjacent p orbitals in the system. So all of these p orbitals can delocalize electron density with one another here. But now when we get to a triple bond, so I'll actually redraw this triple bond so we can fully understand what I'm talking about. So once we have a triple bond, well, we have first a sigma bond, which is overlaps directly on the bond. So that's your single bond. Then we have two pi bonds. Well, one of these p orbitals actually is localized between these two carbon bonds here, the carbon-carbon bonds. So we actually have a p orbital that's like this, in addition to the p orbitals like in the alkene bonds that go up and down like this. So now we have three bonds shown here, the blue, green, and red. But the only thing that can delocalize are these green electrons that can delocalize with the neighboring p orbitals that are also going up and down. This p orbital or this pi orbital that's in the plane of the sigma bond or plane of the bond or perpendicular to these delocalizing p orbitals aren't actually able to delocalize with anything. It cannot happen. So in essence, even though we have four electrons here in this triple bond, only two of these electrons are able to delocalize because the other two are being caught up in between these two carbon-carbon bonds. So what we have is we actually lose two of these electrons in the number of electrons that can delocalize. So we only have 14 pi electrons that can delocalize. Now, C asks, why is C aromatic? Well, to be aromatic, you need to be cyclical, which this is. It needs to be fully conjugated. That means every single carbon must be an sp2 or sp, which it is. And number three, you must follow Huckel's 4n plus 2 pi electron rule, which this actually does, because we see if we input n can be any positive integer or 0. So if we input n to be 3, we actually get 14. So this follows Huckel's 4n plus 2 pi electron rule. Therefore, this molecule is aromatic.